All right, next we're going to look at the monopolist's cost and how they go about maximizing profit, which is what all firms do. All firms are trying to maximize profit. So, of course, we're going to assume the profit maximization model here, just like a perfectly competitive industry or firm. Okay, so that is one similarity they have, is they're both trying to maximize profit. Now, the perfect competitor just has to decide on the profit maximizing output. It doesn't have to make any choice about price because it's a price taker. So that's a little bit easier for the perfect competitor, but for the monopolist, it's a little bit more complicated. So they not only have to determine the output that maximizes profit, but once they determine that level of output or that quantity to produce and sell, they then have to determine the price to sell it at. Okay, so there's kind of two steps for the monopolist. They're looking for a price-output combination, not just an output level like the perfect competitor. They're looking for output and then what price do they have to charge so they can sell all that output. So they're a price searcher or a price maker. So as it turns out, all these other firms that we're going to see, so we're going to see two other types of firms after this chapter, but every firm other than perfectly competitive firms are price searchers. And it's because they face a downward sloping demand curve. Okay. Now we can determine the profit maximizing price output combination with one of two equivalent approaches. So one approach is to look at total revenues and total costs and maximize the difference between those things. Or we can use the more common approach and look at marginal revenue and marginal cost. And so we actually saw this already with perfectly competitive firms. But let's take a look at these, right? So using the total revenues, total cost approach, the firm is just trying to maximize the positive difference between total revenues and total costs. So we've already seen this actually. We've actually seen both of these with perfect competition. So this should just be a review for you. So that's one approach. The other approach, using marginal revenue and marginal cost, is looking for where these things are equal, right? So profit maximization also occurs where marginal revenue equals marginal cost. So why produce where marginal revenue equals marginal cost? As it turns out, this is exactly where the greatest difference between total revenue and total costs occur. Okay, so looking at some information on a table here, we've got output in the leftmost column. We've got price per unit. Now, of course, there's an inverse relationship here because of the law of demand. So basically what we have here in the first two columns is a demand schedule. And then in the third column, we have total revenues, which is just the product multiplying these two things together. Very easy to see here when output is 1, right? But you can verify for yourself that the numbers in this column are just the product of the two numbers in these two columns. And then here we have total costs given, and of course total costs are always increasing. And then we're given profit, which is just going to be the difference between total revenue and total costs. So in this case, 0 minus 10 is negative 10, so a loss of $10 there. Then you can verify for yourself that these numbers are just the difference between column 3 and column 4. And then we're given marginal cost here. So where is marginal cost coming from? Well, it's just the difference between total cost going from one row to the next. So going from 10 to 14, the marginal cost is 4. So producing one more unit costs $4. I'd actually prefer if they shifted this down one row, but so the marginal cost of the first unit is $4. Okay, so I should edit these and push these down one row, but basically it's just marginal cost, right? What's the additional cost of making one more unit? It's just the change in total cost. And then marginal revenue, similarly, is just the change in total revenue, right? Going from one unit to the next. So here we've got $7.80 for the first unit. So producing the first unit increases total revenue by $7.80. And you can verify these for yourself for the rest of those. All right, and then graphically, we have a pretty similar picture to what we saw with perfect competition, right? So over here, we've got the total revenue, total cost approach. So total revenue here is the green line. Total cost is the black line. So when costs are greater than revenues, as we can see here and also here, these are losses. These orange areas or peach colored areas are losses because costs are greater than revenues. And then in this green area, when total revenue is above total cost, we have profit. And the firm is trying to find that place where the gap here is as big as possible, right? Total revenue is as high above total cost as possible, which looks like occurs at 9 units. If we instead look at the marginal revenue, marginal cost approach, which is more commonplace in economics, we see that where that profit maximizing output occurs is where marginal cost equals marginal revenue. Now again, to recap on this, just like we talked about in the last chapter, the reason for this is because when marginal revenue, which is the black line here, is above marginal cost, this difference here is basically marginal profit or additional profit, and additional profit is positive. So these units are providing additional profit. And when does that stop? Well, it stops when they are equal. Now, if the firm was to produce beyond that point, we now get it to a point where marginal costs are above marginal revenues, and so rather than additional profits, we now have additional losses. So the firm, of course, does not want to keep producing beyond this point. It would start losing money. And it doesn't want to produce somewhere over here because if it produced more, it would make additional profits. And again, that stops right where marginal revenue equals marginal cost. So you can see that the quantity that maximizes profit is the same in both cases here. There's the gap that's the biggest in the total revenue, total cost approach. And then if we're just looking at where marginal revenue equals marginal cost, it's right there. It's the same output. I think one reason this approach is more commonly used is it's easier to tell graphically where it is, right? It would be difficult to know exactly where this gap is the biggest, right? You'd have to get out a ruler and try and figure that out. Whereas here, it's very easy. You don't need a ruler or anything. You just find where marginal cost crosses marginal revenue, right? Okay, so that gives them the profit maximizing output. Okay, so I already described this. So producing beyond the point where marginal revenue equals marginal cost, well, that's where we have the firm has additional losses. Producing less than that level of output is where the firm could produce more and get more profit. So of course it doesn't want to stop. It doesn't want to stop until it gets to this point, but of course it doesn't want to go past that point. Okay, great. All right, so remember that that's not the end of the story for the monopoly, right? It's looking for the price-output combination that maximizes profits. So here we've got marginal cost and marginal revenue. That's where they're equal. So this is the profit maximizing quantity, but that's not the end of the story. Now the firm has to determine, the monopoly has to determine how much to charge in order to sell that amount of output. Well, that's what the demand curve tells us, right? What can the monopoly charge and sell that amount? Well, it's given to us by the demand curve. So if you're doing this exercise yourself, you would start by finding where marginal cost equals marginal revenue. That determines quantity. And then you go from that quantity up to the demand curve to figure out the price that the monopoly can sell that quantity at. Okay, so there are some real-world limitations to this. It's not necessarily this clear-cut for the monopolist. It's a process, right? The monopoly has to kind of try some things out mainly because it doesn't exactly know what the demand curve is with 100% certainty. It might have a good idea. It might be able to estimate it, but it doesn't know for sure in most cases. And so it's kind of like a, trial and error to some degree, right? Let's try this price. Okay, let's try maybe lowering price and selling a little bit more. Does that increase profit? No. Okay, let's try going the other direction, right? So again, it's a process. It's not necessarily as clear cut and dry as this. Although it would be if the monopoly knew exactly the demand that it faced. But in most cases, it can only guess or estimate the demand that it faces. All right, so let's think about an example real quick. Want to raise the price of heart drugs, so pharmaceutical drugs for heart conditions? Create a monopoly seller. So recently, a pharmaceutical company purchased two of its competitors that produce drugs targeted at particular heart issues. And immediately following the acquisition of these companies, they raised the price of those heart drugs. Clearly, the monopoly prices were higher than when the prices were in a more competitive environment. Okay, so that's basically kind of what we're getting to here is that the reason that monopolies historically charge higher prices is because they don't face competition and they're trying to maximize profit. Okay, so how do we find its profit graphically, right? What does it look like in our graph? Well, or even mathematically, really. It's given by the shaded area in the next figure that we'll see, which we'll see in a second. But mathematically, in an equation, it's basically just equal to total revenues, which we already know is price times quantity, minus total costs, which we can calculate as average total cost times quantity. And in fact, this is nice because if you wrote this out, right, you'd have P times Q minus ATC times Q, and you could factor Q out so that you get Q, right, this is equal to Q times P minus ATC in parentheses. So I'll show you what that looks like graphically. All right, so here we go. Here's our marginal cost curve. Here's our marginal revenue curve. That's where they intersect. That's the profit maximizing quantity. We go up to the demand curve from that quantity and over to the price. So there's the price that the monopoly will charge. Looks like it's about $6.20. Okay, great. And as it turns out, right, here's Q, here's P. So this big rectangle that's outlined by the dotted lines, that is total revenue. Okay, and then we've added in one more curve here. We've added in our average total cost curve. So if we go from that quantity up to average total cost and over to the price axis, that's telling us what the average total cost of production is. How much does each unit on average cost to produce? Okay, so if the firm is selling it, if the monopoly is selling it at this price, and on average it costs this much to produce each unit, the difference there, that height, is profit per unit. What is the profit that each unit that they sell, that they make and sell, give to the firm? Okay, so the height there is profit per unit, and then to get total profit, all we got to do is multiply that by Q. Okay, so this is exactly the equation I was just talking about, right? Here's P minus ATC, the height right there, right? So in parentheses, price minus average total cost, that's the height right there. And then if we multiply it by Q, that gives us total profit, okay? Now, another sort of misconception is that monopolies always make a profit, and that's not the case. There is no guarantee of profits for a monopoly. If people suddenly decided that diamonds were junk and they didn't want them, De Beers would not make a profit, right? If the average total cost at every single point along it is above the demand curve, there's no price output combination that will allow the monopoly to recover its costs. So let's see if we got a picture of that. Here we go. Okay, so this is what a loss situation would look like for a monopoly. So again, this is the same trick that we used that I told you about for perfect competition to easily tell whether it's making a profit or a loss. All you got to do is look at this average total cost curve and see if it dips below the demand curve. If it doesn't, the firm is going to make a loss. But if it does, like we saw in the previous graph earlier, a couple slides ago, it did dip below the demand curve, and in that case, the firm will make a profit. So we can use that same visual graphic trick, but this is what a loss situation would look like for the monopoly. Now, it's still going to try and maximize profit, or same thing, minimize loss, by producing where marginal cost equals marginal revenue, producing that level of output, going up to the demand curve, and charging that price, right? So it's still profit maximizing or loss minimizing, same thing, two sides of the same coin. So it's still doing that, but in this case we've got a loss because the average total cost is greater than the price. So here we have loss per unit, and then the height here is loss per unit, and then if we multiply that by the number of units produced and sold, we get total loss.